Hey everybody, it's Mr. N, and we are going to do the next lesson, and this is on properties of parallelograms. So first, let's take a look at what the definition of a parallelogram tells us. So I will slide this up, and it says it's a quadrilateral with both pairs. Notice the key word here, both pairs of opposite sides parallel. So both pairs have to be parallel. Doesn't say anything about congruent, right? It says both pairs of opposite sides parallel. That's the definition. It's in the word parallel, parallelogram. So both pairs of opposite sides parallel. So here we go. We've got this quadrilateral, both pairs of opposite sides parallel, and it's a parallelogram. So our first theorem that we can conclude is if we have a parallelogram, the opposite sides will be congruent as well. So parallelogram means opposite sides congruent. Again, the definition says opposite sides parallel. The theorem tells us that opposite sides will be congruent. So here's another theorem. If you have a parallelogram, then the opposite angles will be congruent. So angle B here will be congruent to angle D, A to C. And another theorem, if you have a parallelogram, then the consecutive angles, so same side interior, will be supplementary. So A and B are supplementary, C and D are supplementary. Now all of this goes back to when we learned about parallel sides or parallel lines cut by a transversal. Here's our transversal. These are the interior, same side interior, right? And then you can set up, if you extend these out, alternate interior angles and things like that. That's how you prove these theorems. And then finally, if you have a parallelogram on this one, the diagonals will bisect each other. So B to D will bisect A to C. They won't be the same length. Notice AC is obviously bigger, but they will bisect each other. So that's something that we can talk about how to prove later. But to give you a quick hint, you can make the triangles out of that and you've got vertical angles there. Okay. All right, so taking a look here, let's look at the next page. And we've got all the same theorems here that I had just talked about. And this is how they are presented out of the Big Ideas book. Okay, so there's the diagonals, there's the consecutive interior equals, or the consecutive angles theorem where x and y here will be 180. Opposite angles will be congruent and opposite sides will be congruent. All right, so let's go ahead and do some examples now. I'll slide this up and we'll start with these. All right, so for number one here, it says, find the values of a, b, x, and y. So over here, let's start with this one. If this piece is 12, a will be 12. This is 7, so b will be 7, and that's because we have a parallelogram here, and opposite sides will be congruent. Now, since this is 112, x will also be 112, right? X will be 112 right here. Opposite angles are congruent, and so since over here that's 112, these will be supplementary, which will make this 68 degrees. Taking a look at the next one. This is 5, so B will be 5. This is 6, so A will be 6. Now let's do these. So Y will be the same as this one, which is 74 degrees. And X, remember, these are parallel, so you have alternate interior angles, so X will be 60 degrees. All right, moving on to number 3. Over here, that's 10, so B is 10. A, remember, the diagonals bisect each other. So if this diagonal piece is 10, A will also be 10. Okay, now, taking a look at this, we see that this piece is 10 right here. Oops, this piece is 10, and that piece is 10. That makes this an isosceles triangle. So since that's 10 and that's 10, that means X will equal Y. And since we have alternate interior here like this, because these are parallel, this is 62 in here, which will make that 62 in there. So 180 minus the 62 gives me 118 for the X and the Y combined. So that means X will be 59, Y will be 59 degrees. All right, moving on to the next one. I'm going to zoom in a little bit here. There we go. So we can see it a little bit better. Now we've got a couple values here that we could take a look at. And this is 70, so that's 3y. So right away, let's look at a, though. That's going to be 20, so that part's easy, okay? We also know that 28 will equal to b, so b will be 14. So we've got all those. Now let's look at the x and the y. 42, 3y, these are parallel, so 42 equals 3y, so y will be 14. And then we can say that this 42 plus 70, so 42 and 70 is going to give me a total of 112. And adding, right, these are going to be consecutive. So 112 plus the 4x will equal to 180. So 4x will be 68. So x will be 17. All right, so we've got a, b, x, and y. All right, so let's move on to the next one. Slide it up a little bit. I'm actually going to just reduce this just a teeny bit, and let's take a look. Over here, we've got 2y plus 12, 4y minus 4, so we can set these two equal to each other. So 2y plus 12 will equal to 4x minus 4. Oops, this is a y, 4y minus 4. So now we can go ahead and solve for y. So that's 2y equaling 16, so y is going to be 8. So that part was pretty quick and easy. So now let's do these. These are opposites on a parallelogram, so they will be congruent. So 8x plus 13 will equal 11x minus 23. If I bring it this way, this will be 3x. Bring that one the other way, will be 36, so x will be 12. So we've got our x and our y for this particular problem. And I believe that was it on this one. I've got one on the other one. Let's zoom in a little bit on this, and we will take a look. It says write a two-column proof. We are given that this is a parallelogram. We need to prove that triangle RSU, which is this triangle in here, is congruent to TUS, which is that one right there. So let's go ahead and make our T-chart, and we're going to do it statements and reasons. The first one is RSTU is a parallelogram, and that is our given. All right, let's take a look at our next step. What we are going to do, since it's a parallelogram, there's a lot of things I could say. I could say that RS will be congruent to UT. So let's do that one. RS will be congruent to TU, okay, and that's by the theorem that tells us that the opposite sides of a parallelogram are congruent. So we'll just say opposite sides of a parallelogram are congruent. Well, with that same reasoning, I could say ST and UR. So ST is congruent to UR. And then I can say that SU will be congruent to SU right here by reflexive. And thus, our final step is that triangle RSU is congruent to triangle TUS, and this is by side, side, side. All right, so we'll leave it at that. Hope this wasn't too bad, so thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.